Hello, welcome again. We are solving some questions of heat transfer. The topic is one-dimensional heat conduction. Question number 18 is a steam pipe 10 centimeter outside diameter is covered with two layers of insulation, each having a thickness of 2.5 centimeter. The average thermal conductivity of one material is 3 times the other, and the surface temperature of the insulated steam pipes are fixed. The percentage saving in dissipation when the better insulator is placed inside then that of the better insulator placed outside is option A 7.55%, option B 18.55%, option C 9.12%, option D 15.13%. So here the geometrical dimension of the steam pipe are R1 is your 5 centimeter, okay, and the thickness of insulation is given as 2.5, so R2 will be your 7.5 centimeter, okay, and there are two insulations, so outer radius will be outermost radius will be 7.5 plus 2.5, that is 10 centimeter, and one of the insulation having conductivity K and other will be having conductivity 3K. So the better insulator will be the metal that it will be having lower conductivity. Suppose this is your K1 and this the metal which is having higher conductivity is the poor insulator. So suppose now the better insulator set is placed inside and next to steam pipe. So then the thermal resistance will be 1 by 2 pi K1. K1 is for that K, okay, better insulator. L log E R2 by R1. So that is the thermal resistance offered by this better insulator, and other insulator is placed next to the pipe. So that insulation will be thermal resistance will be log E R3 by R2 1 by 2 pi K2L. K2 is your 3K. Okay. So if we put the value of K1 and K2 as K and 3K and R2 and R1 and R3, then we can find out this thermal resistance as 0.2506 pi Kl. Okay, and the heat dissipation is given by temperature difference divided by RT, and this is your RT. So it will be 3.99 pi Kl delta T. Okay, and next is when the better insulator is placed outside. So when better insulator is placed outside, then the thermal resistance is this is your thermal sorry, when the better resistance is placed outside, then this K2 will come inside and K1 will come outside. So 1 by 2 pi K2L log E R2 by R1 plus 1 by 2 R3 by R2. Okay, so just we will and other thing will be same. Okay, here is and K, here is K. So we put the values. We have thermal resistance 0.2114. Your delta T divided by 0.2114 by K. Okay, dividing by resistance. So that is now the heat dissipation is 4.7303 pi K L T delta T, and initially the heat dissipation was 3.99 pi K L delta T. Okay, so the percentage saving in heat is now here the heat dissipation is more when better insulator is placed outside, and when the better insulator is placed inside, then the heat dissipation is less. So percentage saving in heat is where when better insulator is placed inside, that change in heat is this, and this is your divided by 3.99. 3.99 means we are taking this as base when better insulator is placed inside. Okay, so that is the advantage to us. So that is so percentage saving in heat is here 18.55%. Okay, now next question is steam pipe is covered with two layers of insulating material with a better insulating material forming the outer part. If the two layers are interchanged, the heat conducted option A will decrease, option B will increase, option C will remain unaffected, option D may increase or decrease depending upon the thickness of each layer. Okay. So in the last question we have seen that when the better insulator is placed inside, the heat transfer is less. So here in this question, the when the better insulating material is forming the outer part, the heat transfer is more. Okay, because it is forming the outer part, and when it is placed inside or when it is interchanged with the inner part, so heat transfer will decrease, because so answer to question number 19 is A and answer to question number 18 is B. Okay. Next, a pipe carrying saturated steam is covered with a layer of insulation and exposed to ambient air. The thermal resistance are shown in the figure in the following figure. So R steam, R pipe, R fin, R insulation, R air. Which one of the following statement is correct in general in this regard? A. R steam and R pipe negligible as compared to R insulation and R air. B. R pipe and R air negligible as compared to R insulation and R steam. C. R steam and R air are negligible as compared to R pipe and R insulation. D. R insulation and R air are negligible as compared to R pipe and R steam. So the resistance of steam and resistance of pipe, because conductivity of pipe is very high as compared to insulation, so this resistance, this will offer a small resistance, and steam is also very conductive, uh, or the heat transfer in the steam to pipe will take place due to convection, so its resistance will also be small. So these two resistance are small as compared to these resistance. So answer to question number 20 is option A. Okay.